Hi math students, and welcome to another algebra video. This lesson is going to be on something called literal equations, specifically how you solve literal equations. Now as you're reading this, I know you guys know what equations are, because that's what our first two lessons have been on, but I would probably be asking myself if I was a student, what is a literal equation? What do you think of when you hear the word literal? That's going to be where this lesson starts. So lots of times when I teach this in class, students say, oh, literal, like literally. And it's not quite where that word comes from. Instead it comes from the same place that words like literature comes from. You know, literature is reading, lots of words, lots of letters. It's the same idea. A literal equation is going to be an equation with multiple letters, which in math we call variables. So we're going to be looking at equations with lots of letters in them. Now when students hear that, they're like, oh my god, I've never seen that before. But actually you have. Instead, lots of times before this point, instead of calling them literal equations, you call them formulas. So for example, a lot of our algebra students have seen at some point before this class, this formula here. This is the formula for area. It says area equals length times width. It's a formula, but it's also a perfect example of a literal equation. It's an equation, because it has an equal sign, with multiple variables. Now some literal equations we're going to look at are going to be like this. They're going to be a formula and have meaning. Other times it can just be any equation that has lots of letters in it. So for example, something like 2a plus b equals 5c. That doesn't mean anything, it's not like a formula, I just made it up. But it's an example of a literal equation because it's got multiple variables in it. Literal equations can still have numbers in them. To make it a literal equation, it just has to have more than one variable. So we said today what we're going to be doing is solving literal equations. Now when you solve like your basic equation that only has one variable in it, solving means getting that variable, that one variable all by itself. So if the equation is 2x equals 4, solving it means saying, what does x equal? Well, x equals here, 2. When it's a literal equation, because there's multiple variables, the problem's going to have to tell you what you want to solve for. So if there's A, B, and C, I could ask you solve for A, I could ask you solve for B, could ask you solve for C, and those will be 3 different answers based on what you're looking to find in the problem. So as fun as that sounds, let's go ahead and begin these. One of the things I usually see when we're in the class is, oh my god, like they've put letters in math and now they've just like taken out all the numbers in math, like what's happening? These I recognize can look a little crazy when you first see them, so what I really like to do in this lesson is compare it to something you already know. So this right here, x plus 3 equals 5, is an equation you already know how to solve. I'm going to have you go ahead and try solving this now. Okay, so to solve this equation, some people again like putting that line there. You would subtract 3 on both sides because we are doing the opposite of what we see there. The opposite of plus 3 is minus 3. When you do that, the 3's give you 0, and you're left with x equals 2, which is our answer. We solved for x and got x all by itself. Now with this literal equation, we're going to go about it the same way. If I want to solve for A is right here, and just like before we ended up canceling the number that was with x, here to get A by itself, I want to cancel the variable that's with A. So in this case, that's the plus B. Now if I want to get rid of plus B, just like before, I'm going to do the opposite. So just like before, the opposite was minus 3. Here, the opposite would be minus b. Also, just like before, whatever you do on one side, you're going to do on the other. Same thing is true here. Whatever we do on one side, we do on the other. Also, just like before, the 3 minus 3 is 0. And since 0 is nothing, we were able to cancel them out. The same thing is true here. B minus b is 0. 0 is nothing, so those cancel out, leaving you with A. The place where it starts to actually be different is this last part here. When you have numbers, you could actually subtract those, right? 5 minus 3 is 2. Over here though, I've got C minus B. Those are letters, I can't subtract them. So the one thing that's really different about this is instead of having a single term, one thing, for your answer, here, since I can't subtract these, I'm just gonna copy down and write exactly what I see. I'm gonna say A equals C minus B. And that can look a little weird, but that is your answer. Remember what the goal was. We want to solve for A. Did we do that? Yeah, I got A all by itself. Just instead of equaling a number like we're used to seeing, now it's saying A equals C minus B. So again, I like this idea of going back to what you already know and thinking about what steps you would solve equations like this to help you with these fun-looking equations we're gonna do today. So I've got a couple more like this with the comparison. So for this next part, we're gonna do the same thing. I'm gonna have you solve this first equation. There's a couple different ways you can do it, so do whatever comes to mind for you. All right, so in order to solve this equation, because it's got division, we wanna use multiplication. You can come in and multiply both sides by 4, so that you get x by itself, and you would get x equals 24. Some people also really like solving these equations by cross multiplying. So instead of writing 6 like we have in the original problem, you could change it to 6 over 1 so that it looks like a fraction, and then cross multiply that way. Either way, you're left with x equals 24. Notice, depending on which way you did it, notice what step you used to solve this basic equation here. See if you can apply that same step to solving this literal equation here. Go ahead and just try to see where you're at. All right, well, looking at this equation here, if I wanted to solve it in a similar way to this one, notice if I'm trying to get A by itself, I need to get rid of the divided by B. Just like over here, we did the opposite of dividing by 4, which is multiplying by 4. We could come in and multiply both sides by B. And when you do that, just like over here, these B's cancel and you're left with A all by itself. Now on this side, we've got C times B. Some students write exactly this. They write C times B, which isn't wrong. You can, I mean, it says what we want it to say. But the most common way you're gonna see it is just CB. We've learned in math that when you've got two things next to each other, it means multiplication. So I don't need to put any multiplication sign between these. I can read this as C times B, or CB. So this is one way to do it. If you really like cross multiplying, you could have also solved this equation this way. So I've got A over B. To make C look like a fraction, I could say C over 1. And then cross multiply. A times 1 is just A, since anything times 1 is itself. And then here, the B times C, just like before, we can write CB down. Or, it doesn't matter which way you multiply those, just like 2 times 3 and 3 times 2 are the same thing. C times B and B times C are also both the same thing. So both of these answers say the same thing, and both are good solutions for solving this equation for A. Got one more like this. Look at this fun one here. So again, start off with this basic equation. What operation would you need to solve this one? Good, division. We would come in and divide by 5. Which gives you 6. Try doing that same exact work over here to solve for A. Make sure your answer says A equals. Well, let's see. Over here, if I want to solve for A, that means I need to get rid of B. Now, just like in that last problem, we were talking about this right here means multiplication. It means A times B. If I want B to cancel, I need to do the opposite of times B, which just like over here is division. We can come in, make sure you're dividing by what you want to cancel. If I want A by itself, I need to cancel B, so I want to divide by b. That leaves me with a equals, can't do this division, so I'm just going to copy down exactly what I see. I'm going to say a equals c divided by b. And that's our answer. Now what all of these problems had in common is they were all one-step equations. Each time there was one thing we needed to do to get the answer. One thing we needed to do to get the answer. Just like with basic, normal, one-variable equations, how sometimes these equations can have more than one step, the same thing can be true with literal equations. So we can make these problems even more fun by adding on more steps, right? Making it a little more challenging to solve for that variable. So going back to these basic equations, go ahead and solve this one. Nice. What I really want to point out when you are solving this is if we want to solve for x, where did you start? Well, to start, you're always going to begin with that constant, that number that's by itself, the number not with the variable. So in order to solve this equation, you start by adding your 7 on both sides, gives you 3x equals 9, and then you could go ahead and divide. Now I wanted to point out where you have to start because that order of steps is important. That order is going to be the same order we want to use over here. So looking at this equation, we want to start, if we want to solve for a, by getting rid of which variable in this equation? C. Just like over here, we started with 7 because it's the constant. We are subtracting 7. Over here, we're subtracting c. That's our constant. That's where we want to start. So I would come in to get rid of my minus c. I would say plus c, plus c. Also, just like before, negative 7 plus 7 gave you 0. Negative c plus c gives you 0. They cancel. And we get ab equals, what's going to be over here? Well, I see d plus c, so I'm going to write d plus c. Now, the difference is I need to solve for a. So unlike those problems before, I'm not done yet. I've got one more step. If I want to solve for a, that means I need to get rid of b. So I want to cancel b. How am I going to do that? Divide. If over here we had 3x, that means 3 times x. The opposite of multiplying is dividing. Same idea here. This is a times b. The opposite of times b is divide. So I'm going to come in and divide by b. Now the one thing I normally point out to students is when you're doing that division, you're dividing both sides. You're dividing the entire side. So over here, if you're writing it by hand, you need to make sure that division line goes all the way across. Just say I am dividing this side, this quantity by b, and then we're left with a equals, well, can't do any of that math, so I'm just going to write d plus, I hope that looks a little like a multiplication sign, sorry, d plus c, all divided by b. Now since we are on e-learning, I just want to show you what this would look like if you wanted to type it. If you typed, I'll put it up here, if you typed a equals b plus c divided by, did I say b or d? D, I'm sorry guys. D plus c divided by b. The way this is actually read is d plus c over b, which isn't what we're trying to say. To show that you're trying to divide all of this by b, if you were typing it, do you know what you would need? You would need to put parentheses here. Putting parentheses there shows you're dividing this entire amount by b. When it comes to typing math, we know it's like a skill in itself and it can be difficult, so please don't stress too much about that. But I imagine at some point while we're online, you might have to type something like this, which is why I'm bringing it up now. But this would be our final answer, this, or if you're typing it, this, we've got a equals this fun-looking quantity. This is the last of those comparison ones. I've got 2 last examples, and then there'll be some for you to finally try. This lesson, I start off with a lot of examples because, like I said, this is usually something students look at like, oh my God, like what are you showing me? And so I think it's helpful to to see a lot of examples first before you're asked to solve some on your own. So the two last examples I've got look like this. I think the major way they're different from those other ones is now I've also got some numbers mixed in. They're still literal equations because there's still more than one variable, but I've also put some numbers in too just to give you a variety of examples. Looking at this first one, notice like we said at the beginning of the lesson, it's gonna have to tell you what to solve for, because you could also solve this equation for x if you wanted to. But here, we're gonna be solving for y, which is right here. By the way, this example is here because this is a skill you're gonna be doing a lot in about like 2 weeks. It's specifically solving equations that look like this for y. So this skill is gonna come in handy in your future. If we wanna solve for y, I'm gonna go ahead and put that line there, just like I said, because it helps a lot of students. If I want y all by itself, I need to get rid of everything on the same side as y. Where do you think I'm gonna begin? What's my first step going to be? Now, just like before, if there's more than one thing you're gonna need to cancel, you wanna start with the constant, which is the part that's always added or subtracted to where your variable's at. Here, our constant is 3x. Notice that 3x isn't with the y, we're not multiplying it with the y, it's just this part over here that's being added or subtracted. So here, if I want to get rid of 3x, right now it's a positive 3x, I want to subtract 3x. And I'm going to do that on both sides. And when I go to do that, what's left? Well, over here, those cancel, and we get negative 4y. On this side here, what's left over there? Now in class, there's always a couple people who say, 8 minus 3, 5, you get 5x. Don't forget that you cannot subtract or add two terms unless they are like terms, which means that they need to both have the same variable. I could do 8x minus 3x. That equals 5x. But a number and a variable, you can't combine. So we can't subtract these numbers. All I can do, just like before, is say 8 minus 3x. Again, I can't subtract those because they both don't have x's. So I leave it like this. Now the last part, if I want to get y by itself in order to solve for y, what's my last step going to be? Well, this right here is multiplication. I want to do the opposite, which is division. So I want to divide by my negative 4. Divide by my negative 4. Over here, the reason those cancel is because negative 4 divided by negative 4 gives you 1. 1y is the same thing as y. And then over here, what's going on this side? Well, some people want to divide these, and you could do that, but because this line is saying we're dividing everything by negative 4, and I can't divide everything, for now I'm just going to go ahead and leave it as it is. And that right there will be my answer. At some point in the near future again, we'll be doing something similar to this, and there might be a couple more things we do, but if you can get here, I'm very happy. So this is one example. Last example is over here. We want to solve this equation for b, and b is right here. If I'm looking at what's on the same side as b, I see I'm multiplying b by h, and then I'm dividing b h by 3. The place you want to start is with this fraction part. What a lot of students end up doing for a problem like this is just like those ones we did earlier, set it up as a fraction on both sides so that you can cross multiply. Just by getting rid of that fraction, it's going to make it a lot easier for us to solve for the variable we're looking to find. So from this, what would that next line look like? When we go to cross multiply, remember it doesn't matter which side you start on. If I start here, v times 3, sometimes students want to write v3, which maybe looks weird to you. Do you know why that looks weird? Looks a little weird because we normally have the numbers in front. Those are called coefficients. The number usually comes in front of the variable. Number usually comes in front of the variable. So if you wrote that, I know what you're trying to say, but the most common way to see it is 3v. And then on our other side, 1 times bh. We don't need to write the 1 in front. We can just say bh. Now the next part, if I want to solve for b is over here. So all that's left to cancel is our each. What do you think that final answer is going to look like? Well, we can come in and say I'm going to divide both sides by h, which leaves me with b equals 3v over h. Or you could also say, if you like writing it in this order, b equals 3v over h. This is actually a formula. It's a formula students don't see as often. It is for, I'll do my best to draw it, for a triangular prism. So think like a pyramid. It says the volume of the period, which is how much space is inside, is the base times the height divided by 3. It's not a formula we use often in algebra, but it's fun to be able to solve it for a different thing besides volume. Instead of saying volume equals this, we're saying the base of the triangular prism equals this. Well, for this next part, I'm going to give you 2 to try on your own, and then there's one last example we'll look at. So here are the 2 I'm going to have you try. This first one, 2a plus b equals c. I want you to solve for b. Go ahead and try that. Okay. And then this next one says 3x minus 4y equals 8. You want to solve for x. Go ahead and try that. Okay. If you struggled with either of those, or you're still at this point in the lesson like, what is going on with all these letters? Remember, please reach out to us. We would love to help you out on these. This is, they can look crazy, right? There's a bunch of letters in math, like what's happening. So it's okay if you're struggling a little bit. Just please make sure you reach out to us so we know and we can help you. There is one last question we're going to look at, and it's going back to this formula we talked about at the beginning of the lesson. So the first part says we use the formula A equals L times W to find the area of a rectangle, where L is the length and W is the width. And lots of times in pre-algebra, this is the way that formula is given to you, because lots of times the information you're given the length and the width, and you're trying to find area. So it makes sense that the formula says area equals this. However, you can have the same formula look a different way. So in this part here, they're saying instead of having the formula equal area, solve the formula for width instead. So instead of me saying the area of a rectangle equals this, there's a way to express that relationship for the width instead, to have an equation that says width equals this for a rectangle. What we're going to do is I'm going to take my formula and write it down. And just like in those past problems, I'm trying to solve for width. I think sometimes, as silly as it is, I like to just put a little arrow for what I'm looking for. I'm trying to solve for width, so I want it to say the width equals. Well, in order to get the width all by itself, I need to get rid of length. So using everything we've been doing, right? Instead of saying times the length, I want to do the opposite, which would be divide. The most common way I see division is with that fraction, so I'm going to go ahead and use the fraction to say I'm going to divide both sides by length. When we do that, those lengths cancel out, and now we've got width all by itself. That's what it's asking us to do, is solve the formula for the width instead. Well, the width of a rectangle, what does it equal? The width equals the area divided by the length. These formulas say the same thing. They are the same formula. They just look different because they're solved for different things. But they say the same thing at the end of the day. You had a rectangle, let's say the length is 10, the width is 5, that makes the area 50. This formula is telling you the area, which is 50, equals the length times the width. Well, that's true. All we've done is changed around where the numbers go. This formula is telling you the width, which is 5, equals the area, 50, divided by the length, which is 10. This one also says something true. So they're saying the same things, they've just changed where the numbers or I guess since we're talking about formulas, they've changed where the variables in the formula go. It's important in math to be able to manipulate things depending on what you need. So if we were doing a lot of calculating of width, this would be a helpful way to have it. I've talked enough. There is one last one for you to try that's similar to this. Your problem is a really fun one. It looks like this. It says the perimeter formula for a rectangle is P equals 2 times width plus length, where W is the width and L is the length of the rectangle. Instead of having the formula equal perimeter, solve the formula for length instead. Go ahead and try that now. All right. This is the work to go with that answer. So the first thing I would want to do is let's get rid of those parentheses by distributing that 2. Let's multiply the 2. That would give you 2W plus 2L. After that, we are trying to solve for length, which is right here. Next thing I would want to do is get rid of that constant, that 2W. Instead of adding 2W, I would subtract 2W. That gives me perimeter minus 2 times the width equals 2 times the length. Now to get that length all by itself, all I have to do is get rid of that 2 by dividing. The important thing is you want to divide this entire amount by 2. That would give you P minus 2W over 2, oh no, I'm running out of room, equals length. Thank you so much for watching this video. Hopefully you found it helpful, and I will see you tomorrow. Thanks, bye.